Grazie.
Good afternoon, everybody. We're just going to wait sort of another 15-20 seconds just as all of our attendees arrive into the room. I can see that the numbers are dropping in, so we'll be with you in another 10 seconds or so, just as everybody drops in. Okay, fantastic. Well, welcome everybody. Like I said, good afternoon or good morning or good evening, wherever you are in the world joining us from. Welcome to another webinar Wednesday. We've been away for a couple of weeks because we did a special session, if you joined a while back, with TKH and Honeywell. So today we're coming back stronger with a session based on our most frequently asked questions. So today's webinar is called Technology Q&A Session 1. We're going to do a number of these as a series over the next weeks and months as we continue to get lots of questions as we work through our webinars. And we want to make sure that we bring those most frequently asked questions to you. So a little bit of webinar protocol. If you haven't joined us before, you are all muted. However, you can type your questions in Zoom. So please do so today. Use the question and answer application on desktop or mobile, and please type your questions in. We're going to have pauses throughout. We're going to come to you guys live, and we're going to try and make this as interactive as we possibly can. So please use the question and answer tab, and we'll get to your questions throughout the session. There will also be a follow-up email post the webinar. This includes links to the questions that we'll ask or any resources that are mentioned, and there's a quick survey. So if you can answer those 4 questions, it will pop up in another browser, and it really helps us plan our sessions. So little bit of an agenda today. It's pretty simple. We'll do some introductions to the presenters who are on the call. I'll give you a very quick overview of Midstream if you've never joined before, just so you know who we are and what we do. And then we'll dive straight into those frequently asked questions, where I will ask the 2 presenters who are joining me today to answer them live, as well as coming to you guys as you ask your questions within the app, and we can fire those over to the team as well. So who have we got on today? So first of all, if you don't know me, my name is Michael Short. I'm head of marketing here at Midstream Lighting. I've been in the business for just under a year now, but I've got over 10 years experience working within marketing across different industries, from luxury super yachts and homes through to the financial services industry. And I oversee marketing here within the business. But the most important people on today's call are our 2 guests. So I've got Paolo Corno and Yuli Grig joining us. So Paolo, maybe you could introduce yourself first.
Thank you, Michael. Hello, everyone. I'm Paolo Corno. I'm the technical director here at Midstream, and I take care of all the product development of our products, and I oversee the lighting design process. I've been working in the LED industry for about 12 years, since basically the start of the LED industry.
Thanks, Paolo. And Yuli, over to you.
Thanks, Michael, and welcome everybody. It's great to see so many of the regular names joining this session. It's always good to be able to have a interactive discussion. I'm Yuli. I'm one of the co-founders and the commercial director of Midstream Lighting. I tend to focus on things related to sales and marketing and commercial and strategic and contracts and partnerships. So, but you know, when we started this company with Paolo and Alex, the 3 of us had to really split all the tasks amongst ourselves, apart from the technical, which is always with Paolo. So I've tried a little bit of everything, but now I'm trying to concentrate more on the commercial things. So hopefully some of my answers are going to be useful.
Thanks, Yuli. I'm sure they will be. And as Yuli said, it's great to see so many people tuning in every couple of weeks to this. So for those who are returning, I also say thanks very much. So very, very quickly, a quick introduction to Midstream Lighting as a glance. I can see from all the attendees that pretty much every one of you knows who we are. However, for those who are joining us for the first time, Midstream Lighting are a full cycle turnkey specialist manufacturer of LED lighting, flood lighting. And we are design and lighting experts in very, very niche particular industries, and those being maritime, aviation, sports, and horticulture. And we've been around for over 10 years now. Our products that we manufactured are manufactured right here where I am in the UK and in Romania. And the reason we maintain our manufacturing within Europe is because of quality and speed of shipping. We want to be able to work with our partners and our clients all over the world, shipping the best-in-class products at a speed that works for them. Like we've always said, our products are unique, and for us, this is because of our proprietary optics. Now, these are built and designed specifically for the applications they're intended for. So we focus on very key sectors, and we build products that are built within those sectors for very specific applications. It makes us extremely unique, and it means that we can provide a best-in-class solution. We're proud to have our R&D facility out in Italy, where Paolo is based. Those guys have been working hard for years and are still working hard, developing and working on new products and pioneering solutions for the industry. And we see ourselves as not just product development and manufacturing. We actually see ourselves as a solutions provider. So when I say turnkey, I mean that we can support you from start to finish. We can offer design, maintenance support, incentives, training and education, consulting and financing. We are a solution provider as well as a manufacturer. And that leads me to the final point, which kind of puts us in a position where we feel that we can offer more value. We like to be seen as a thought leader. We like to do these sessions and webinars and continue to educate the industry, our partners, our clients, and our peers, so everybody understands the importance of LED lighting solutions for specific applications. So that's who we are. Thanks again for joining us. We're going to dive straight back in. We've got about 15 frequently asked questions to get through in this short amount of time. Plus, like I said, all the questions that are coming in, and there's already a couple that have come in so far. So keep them coming as we go. So my first question, I'm going to come to Paolo for this one. And this is based around what control systems work with Midstream Lighting products. And maybe you could also touch on what we actually mean by control systems here, Paolo. So what are the control systems and which ones work with Midstream Lighting?
Well, yeah, this is a very common question since it's also a very quickly evolving matter. A control system is something which allows you not only to dim the lighting levels that you have on the installation, but also to run diagnostics and fault reporting in order to always keep control of your lighting equipment. Back in the days, you had to go around and check for burnt bulbs. Right now, you can just get an email every time you have a fault on a luminaire, or if you have a change of schedule, you can just set it from your cell phone. Control systems have evolved quite a lot in the past years. We always made sure that our products are compatible with third-party control systems available on the market. We do offer some solutions that we are developing with our partner companies, like we offer solutions from ZetaQ Lab, which is a company we often work with. How do we do that? Our luminaires, they always accept inputs from DALI systems, from analogic systems, 1 to 10 volts, and from PWM systems. This means that I can basically connect any type of node that I want to our products. It could be, the luminaire could come with a radio antenna, a Wi-Fi antenna, or it could just accept a direct DALI wired connection. Also, our luminaires are able to supply a 12-volt auxiliary power output, so we can power these nodes to control the luminaires. In this way, we basically have no limits. We can adapt to any type of technology we want. I wanted to say that our first control system installations, especially in the airport field, used to be all DALI wired, because people, even up very recently, used to trust the wire much more than a wireless signal, because a wire, it's there. Unless you cut it, you have the connection. Like we have a very large DALI wired system in Rome Fiumicino Airport, where they control more than 600 floodlights. They do their scheduling, their fault reports, and it's a very functional system. But lately, we started to see more and more popular radio systems. We're currently supplying a few installations with 868 megahertz radio signals. And right now, the range of this type of antennas is great. They can go for miles, even with obstacles. And it saves a lot of money on the infrastructure cost. Also, another, like one of the latest changes in the remote control for the luminaires has been that customers used to always want to have, let's say, the software that runs this management system on premise, so on a computer physically installed in their office. While now the same service can be provided with cloud systems. So you again reduce the need of hardware on site. And we always been able to evolve our products to follow these trends, and we can offer every type of solution right now.
Okay.
Paolo, do you want to mention a quick couple of words for sports applications? Because that's typically something else as well, isn't it?
Oh yeah, for sports applications, I mean, I'm not talking about, well, there's two very different types of controls for sport applications. When we're talking about small fields like practice fields or school installations, what we offer is always a very simple system, which is remote control based. Again, this system is developed with the ZQ Lab, which basically allows the user to just set the lighting level from a cell phone or from a simple keyboard with 4 preset levels. And this requires no installation of computers, anything. It's something that can just work out of the box. It's installed together with the luminaires and gives full control to either the team that is operating the pitch, or if it's a company which is renting out the use of the pitch, it's very easy for them to control the timing of usage. There's no waste. When the hour is over, you shut off the lights with the click of a button, and you have full control of it. For high-end sports applications, such as stadiums, like for important clubs, Premier League or Champions League clubs, all of our products, well, in that case, we have to use a particular product which we developed, which is able to accept DMX signals. DMX controls is a special protocol which allows very fast communication and very quick response of the luminaires from the signal that has been sent. It can work together with like video installations with the audio console, and allows the customer to create very interactive lighting schemes and like light shows during the team presentation. Of course, we make sure that all of our products are completely compatible with the DMX 512 standard. And we, depending on the geographic area or the special needs of the club, will bring in a partner that is specialized just in the control system and controls and consoles. Sorry.
Right. Thanks, Paolo. And then I think just a quick question to Yuli on this, very quick, because we need to move on. For all of our partners who are on the call, from a commercial standpoint, the fact that Midstream Lighting, the control systems are agnostic and we can work with anyone, that's a really great benefit to our partners when working with a Midstream product, right?
Exactly, Michael. I think what we're trying to say is that we're not tied to any specific manufacturer. We can look into the market for the best solution for the customer, propose various options, and then the customer can choose what works better for them.
Great. Thanks, Yuli. Okay, question number 2. Actually, again, Paolo, this one's for you. What is the average life of LED lights in terms of burning hours being offered by Midstream?
Okay, this is an often asked question, and the possible answers are almost infinite, because a lot of times customers ask, yeah, how long is this light going to burn? And you need to set a parameter for when you consider the light to stop working. Working with LEDs, LED as a semiconductor will not burn out like a light bulb, will just slowly decrease constantly over time. So you need to define when for you the lifetime is over. People generally consider the 70% of the residual flux to be the end of the lifetime of the product, which is actually reasonable in a lot of scenarios. We tend to set the bar a little bit higher and always specify our average lifetime of 90% of residual flux. Because, I mean, that 70% residual flux might be fine as a parameter when you're dealing with the light bulb in your bathroom at home, but when you're have to respect either TV broadcasting levels or like restrictive levels in aviation or maritime for safety, you need to make sure that you take into account your light degradation and you put a limit to just 10 or 20%. So we'll be talking about an L90 or an L80. Those are the parameters we look for. Generally, our Titan range luminaires, they offer an L90 of 63,000 hours. This means that considering an average use of about 4,300 hours per year, you'll be able to go about 14 years before you lose 10% of the flux from your LEDs. Of course, this is not does not take into consideration the dirt or any other external factors which might affect it, like you may scratch your lenses. But regarding the LED itself, this is generally their lifetime. We have sport products for different applications, like in the like medium-sized sports pitches, where weight is more relevant than such a long lifetime. We offer a product which has around 36,000 hours, L90, but hours of usage are much lower there. So you're basically looking in terms of usage years about the same 14, 15 years. Of course, all the burning hours are strictly related to the heat dissipation of the LEDs. As all the semiconductors, the cooler it runs, the longer it will survive.
Okay, thanks, Paolo. And if anybody on the call wanted to get this number to understand more from our product range about this, is there anywhere that can be found online? Is it on our data sheets?
It's on our data sheet. Any product has its own L90 and L80 data on the data sheet.
Perfect. So if anybody wants to find out for each of our individual products, you can go to our website. All our data sheets are on there. Or of course, you can email myself or any of the team and we'll be able to get the information to you, but it's readily available on our data sheets online on the website. So you can check it out there. Thanks, Paolo. So Yuli, the next question is for you, and it's around lighting design. So do we offer a comprehensive lighting design package when we're proposing a system to a customer? And I'm going to add on, how much do we charge for that?
Yeah, thanks. So I think this is a quick answer, and that's good because we need to speed up. Of course, Midstream idea is that we typically wouldn't even quote a project unless we've done the underlying lighting design. For us, this is critical for the success of the customer. So this is a prerequisite. We always start with lighting design. For us, this lighting design is a free service. Okay, and we like to believe that we support our customers all the way through the various iterations and all the various revisions so that they get to the final solution that they actually want. So yes, comprehensive lighting design is part and parcel of what we offer. It's where our expertise lies. It's part of our DNA.
Fantastic. And do we charge for it?
Free.
Just wanted to add that in there. Okay, thanks very much. Question 4, we're back to you, Paolo. What kind of optical system are we using? Asymmetric reflectors or lens optics?
All right, so we have to make a distinction here because we use two different types of optical systems depending on the applications. Let's say that we have a range of asymmetric refraction lenses, which we developed internally. For example, well, most of the aviation installations and maritime, they use asymmetric PMMA refraction lenses. So we basically are able to set the LED module flat to the ground or minimal tilt and have a very good forward pitch of light. This allows us to keep the glare to very low levels, as we discussed in our previous webinar, and also allows to give a very good uniformity on the ground, which is the key parameter in any installation on any field. This also allows for, when dealing with critical infrastructure, to be able to survive, let's say, a product failure. Because if you have a mast with 12 luminaires with an identical pattern, they overlap, and you're able to avoid them in a very large dark area if you have a failure of a product. If you use a symmetrical reflector beam, you miss one light, you miss a part of the area, let's say. Then onto the sports fields, we use a mix of both. So we have a range of product with the newly developed, which is actually not yet on the website, but it will be soon, newly developed asymmetric optic with spill light control. And we also have products with a more, let's say, traditional approach, which is symmetric optics, which could be either TIR, so a total internal reflection optics, or refraction optics, mixed with reflective visors, which serve the purpose to limit the spill light and the upward light ratio as much as possible. An example would be our new product, Modus S, which is a mix of refraction, total internal reflection, and reflectors. So the combination of the three will allow us to give a very good smooth uniformity on the field, but mechanically cut the light as soon as the field is over to avoid spillage and comply with the building regulations.
Okay, great. Thanks, Paolo. On to question number 5. And again, this one is for you, Paolo. Yuli, you have a lot of questions on the tail end of this, actually. So, Paolo, how do you calculate for shadows? And this has come up in a couple of sessions, but particular when we did the maritime session, how do you calculate the shadows, for example, in stacking containers at ports and terminals?
This is probably also applicable to shadows from aircraft. Push in, push out type of settings.
Well, this is a very common question, not only asked during the webinars, but asked generally by customers, because they see simulation and they're like, okay, yeah, but this is everything empty. But when I operate my terminal, which is a port or my aircraft terminal, I will have obstacles in there. And this is a bit a complicated matter, because in order to show compliance to regulation, you have to run your calculations with an empty plane. So if you have to show compliance with ICAO, you have to have a complete empty block in your aircraft stand. If you need to show compliance with OSHA or with the UN or with any other port maritime regulations, again, flat plane. Because let's say that the levels set by the regulators take into account that then there will be obstacles later on. So they're higher than what you would need if you were to calculate with obstacles. Said that, we don't think that's enough to just say, okay, shadows are out of the way. We, when we see critical parts in simulations, we always run a second scenario with the obstacle in place, because you might have a scenario which works perfectly without any objects on it. But for example, you'll get some points where with a very good lighting average, but then you realize that as soon as you put 2 aircrafts next to it, you don't get any vertical lighting in that space, because the shadows will just overlap and you will go from 40 lux to 0 lux. So what we tend to do is always include 3D objects in the simulations, even if sometimes we don't even, it's not part of a submission to a customer. We do it internally to make sure that the quality of the lighting system once installed is up to the customer expectations. Because, and this was a very common question, because container stacks can be as tall as a 5 stories building. And of course, if you don't even consider that during your lighting simulation, you're gonna have a very big surprise after the install. Like,
and sorry, Paolo.
Just one last mention here on the container terminal. What I see a lot in there's a trend of using a 360-degree symmetric type of luminaires in port containers. Let's say that it basically makes an umbrella of light in all the directions. So each luminaire will just cast this umbrella of light. and it works great on paper. When you put a stack in there, like a slice of each of that luminaires will be completely covered by the stack. While if you use a more sophisticated asymmetric optic, which is more directional, doesn't go 360 degrees, you will be able to aim the light beams in the corridors between the containers. And that makes the difference between something which looks great on paper and something which looks great in real life.
Okay, great. Thank you. Yuli, does this type of calculation for shadows fall into our design package that we would do?
Yeah, typically we'd always like to include that and have a discussion with the customer around that because their operational requirements are often beyond what is written down in the regulatory standards. So that's a discussion between the customer and the design team to really get to the light levels they're looking for.
Okay, great. And of course, with all our partners who are on the call, you either know this or you don't, but hopefully you do, that you can always come to us as early as possible for this type of design work when you're looking at projects. And obviously, if you are also an end user, please reach out as well, because we're more than happy to look at this for you. So question number 6, what does the term tilt angle mean, and how does it affect the lighting solution? Paolo, I think you actually had the answer ready for this.
Yeah, this is a quick one. Well, when we talk about tilt, we refer to the angle of which our LED module is sitting. Tilt 0 would be a module parallel to the ground. Going up at steps of 5, you basically, well, actually, I don't know another word for tilting. I don't want to say that tilting is tilting.
Inclination.
Yeah, it's the horizontal inclination of the product. And of course, you always try to keep the tilt as close to 0 as possible, because this will guarantee a 0 light spill, no upward light, and a lower glare, because you're basically masking the light source from the viewer.
Okay, thanks, Paolo. Yuli, question number 7. How do you verify that lighting levels meet the approved design once it's actually installed on site?
Well, this is where the proof's in the pudding, isn't it? I think that, to keep it brief again, one of the biggest challenges in the industry is to convert what is on the paper, on the design or on the specification, into the real results that you measure on the ground. And I think that anybody who's working in lighting has to be acutely careful and aware that unless someone's gone out with a lighting measuring instrument and measured the points on the ground, they shouldn't accept any lighting installation. Verification is really a physical check using a light meter which has been calibrated in the last 12 months, hopefully by an accredited laboratory, and obviously able to read the LED settings as opposed to just a tungsten filament color, and doing the physical checks. Without that, you simply don't know. We've had some absolute amazing stories where the customer, the end user, has said, well, of course we meet the requirements because the supplier told us so, and this is the lighting study he's given to us. And in reality, they were so off being close to the required standards that the local airport authority wanted to shut them down until they rectified that. So always, always, always check on the ground what happens. Don't trust what's happening on the paper. In a lot of instances, manufacturers are not very honest in the performance of their luminaires, or don't even know how their luminaires perform in the field.
Thanks, Julian. You touched on it there, and I think the importance is that in some industries, and in aviation in particular, not having that verification done can lead down the line to major problems, to aprons even being shut down.
Michael, in any application, it's particularly strong for sports. In sports, a lot of people are doing self-certification. So they come in, they install it, and then they do the auditing. It needs to be a third party, or at least the customer needs to come on site and double check that the lighting levels are being measured correctly. Because as a contractor or an installer, that's a third party, he's always incentivized to show light levels that might be a little bit better than they are. So in all applications, I would always double check what's happening on paper and what's happening on the ground. We've made ourselves a reputation for delivering more or equal to or more than what we promise. But unfortunately, a lot of companies out there who are not so well established, and actually some which are, don't always deliver what they promise.
Sure, and we've had a really funny comment from Mike, who's said that he once had a lighting consultant who had done the design, who then went to measure the lux level in the daylight.
Wow.
Yeah, well, we need to get Mike on and asking his questions live, I think.
So great stuff. Okay, we're going to move on to question 8. So Paolo, how do you make sure that the lighting solution meets the environmental requirements in protected environments? And the example here we've got is maritime, where in lots of terminals and ports that we've worked on, there are areas where there are things like nesting sea turtles. There are other environmental aspects, obviously, to do with wildlife. But how do you make sure that the solution meets those requirements? And is there any way, via the design software such as Dialux or in-house in Midstream, where we can simulate and work this out to support the clients?
Yes, I say that most of the environmental requirements, especially in protected maritime environments, which are the most restrictive one, they consider 2 key parameters. One is the spill, let's say the spill light level. So they put a limit on the light level of artificial light that can reach a certain area. And in this case, it's something which is very simple to calculate in Dialux, just by basically reconstructing the scene, setting viewers at the correct distance from your light installations, and you can easily check light intensity and actual illumination levels. Another parameter which is especially important for sea turtles is the light spectrum. So there is a lot of limits on the blue emission of light. So on the 450 nanometer range of wavelength, and actually they put a limit of any wavelength lower than I think is 580 nanometers, which basically restricts the use to only orange monochromatic luminaires. And in that case, it's nothing to do with the software itself, but it's something related to the product. Unfortunately, monochromatic orange LEDs are not very, they don't perform very well. So the payback of those installations is not as good as if you were to use white light.
Okay, and I think the answer to this question is, because of our experience and having undertaken many projects in many of these environments, it isn't something that can just be done via Dialux. It comes from experience and knowledge and working with clients all over the world in these environments, correct?
Yeah.
Okay. So question number 9, when replacing floodlights, do you consider and check the structural resistance of the masts? And Paolo, I think this one was aimed at you.
Okay, yes. Well, when we do retrofit jobs, so when we have to go retrofit our luminaires into an existing infrastructure, the first step is done during the design phase, which is understanding from the customer what is the weight they have currently on the mast and what is the size of the products currently installed, so we can calculate the wind edge exposed surface. And our goal is always to keep within the limits of what's installed today, because in that case, you know that the mast has been certified for that weight and that wind load. So if you reduce it, you're always on the safe side. In case when this certifications, this paperwork is not available or the mast is too old, then we always suggest, and we have a pretty good network of partners who can carry out these structural checks. They'll do a check for corrosion at the base of the mast. They'll redo the calculations and the check on the crown of the structure. We're actually currently doing the same thing for a port installation in Europe, where the masts are a little bit ancient. The paperwork is gone, And so somebody needs to actually go check the thickness of the steel and rerun calculations.
Okay.
Yeah, so basically they undertake some non-destructive testing, NDT testing around the base of the mast, around the concrete foundations, around the anchor bolts. I think people should remember that when we are considering structural integrity of a high mast, the biggest stress is going to be at the base where the metal meets the foundation. That's the shear stress that's going to be the most critical. It's not really at the top of the mast where people think it's around the moving or the shaking of that particular structure. So I think it is important. We've heard it, we've all read in the press, in the newspapers about masts collapsing, hurting, injuring, or even killing people. So it's no joke. It needs to be considered very carefully. These masts, they weigh 2 or 3 tons, some of them, and they can go up to 30 meters, 40 meters up in the air. And then you add on top of that the weight of the luminaires, which can be significant. So yes, it is a serious engineering point of consideration.
Great, and I think that from my side here, our detailed and precision is not just in the luminaires that we manufacture; it's in every step of the process. And this is just one example of where we do not let things slip, and our details within even this sector are extremely high. But for our partners and for our clients, that is kind of our job, is to simplify this complexity and make sure we handle this for you. So it's something that we're extremely proud of, to be able to go through this process and work on. So question 10, Yuli, this is a fantastic question. It always comes in, I'm sure, when you guys are always in your sales meetings or in negotiations or in tenders. This is probably something we get asked all the time. So what is our price position compared to the competition?
Yeah, this is definitely a commercial question. And one that happens almost every time you introduce the product to a new partner or a new customer. And I always like to say that, there's no use in comparing the price of one luminaire compared to another. We always need to look at the cost of the solution, and not always just the cost, but also the value of the solution to the customer. Because, there'll be certain customers which are looking only for the cheapest option, and those, frankly, are not our customers, and we don't need to chase those particular projects. We work with those that appreciate the value and the quality of our products. But we do sell, and we win projects on tenders in Africa, in India, in South America, like Ecuador and Peru, or in India, and in some East European countries, which are typically considered to be low-cost countries. So we are successful in all environments. We are successful in North Europe too. So I think that the way to answer it is that we are incredibly competitive if we are able to run the design and run the project and offer the solution compared to another solution. Maybe if you look at a product per product price, we're not the cheapest in the market, and nor do we strive to be. But certainly when it comes to providing the whole solution, we are for sure one of the best priced and most value adding providers out there in the market, I believe. And that's generally proven by the fact that we have almost more case studies in our chosen fields than any other company.
Thanks, Julian. I think if anyone wants to get an example of price positioning and the importance of that, you should go back and watch the James Brunt Sports Stories session, where he explains some interesting stories about some of his large sports clients who made the wrong choice from a price perspective and paid for it later. But that is an episode previously, so if you ever want to head back and watch it.
Here's a comment, Michael, just to come back to that one, from Mike K, who's mentioned.
We've lost you.
We lost you completely.
But I can see the comment as well. And Mike was saying where liability comes at a cost, and there is no shortcut. And we definitely live by that mantra as well here at Midstream. So we'll come back to question 11. This is for Yuli. So I'm going to go to question 12, which is aimed at you, Paolo. Can we always trust what is proposed in the simulation? So what happens if the actual levels are not the same?
Well, let's say that there are two main factors that can influence the real life result against the result of the simulation. One is, well, actually it's more than two, but let's say they're divided into categories. One could be incorrect input data, because, you know, sometimes it happens, incorrect conversions from imperial to decimal measurements, or it could be something like do not take into consideration obstacles and other structures creating shadows, which is often the case in considering terminal aprons in airports, where the apron is attached to the terminal building and you have bridges in the way. So if you actually go do a lighting check and you have just a bridge across your apron, your light level would not technically be up to standards, but that it's a little bit of, let's say, a small mistake which could be easily corrected. The other most, let's say, the worst type of mistake in simulation is when the input data given by the customer is not reliable. Because, I mean, the simulation is not magic. It comes from data. You take your luminaire, you bring it to the lab, you get your photometric testing done, measures how much light is emitted, how it is emitted, what shape, what photometric you get out of it. You plug it into a software, and the software will try to show the most accurate way of how the light will distribute in real life. So when you start with the wrong data, when you know, sometimes there are some producers who just inflate their flux value, or they change the shape of their photometrics so it just looks better at the client's side, but at the end of the day, you don't get the results you were hoping for. In that case, there's nothing you can do to bring it back to the expected levels.
Sure. Okay, makes sense.
Hey, Yuli, you're back.
And we got Yuli back. Thanks.
I was struck down by competitors' bad wishes.
We had a question come in from Murali, and I'm just going to ask it now before I come back to you, Yuli. Is how is the heat sink being designed? So, you know, what is the parameters, I suppose, of our heat sink?
Oh yes, actually, this it's something which is related to. I actually wanted to answer this before, but I forgot because it's very related to the question of the burning hours. When we develop, well, actually, on the practical level, our heatsink is designed using thermal simulation software. So it's a little bit of a trial and error process. But also we have a lot of experience in designing heatsinks. So we know when we need to design a heatsink, we know how to start already. But basically it starts from the goal that we want. So we want to set the maximum junction temperature that we want to achieve on that product. And we have, the other goal is the weight of the heatsink. So we start with these two factors. The junction temperature of the LED is what is going to give us both the performance in terms of lumen per watt and the reliability of the product. Once that is set, we decide what will be the maximum weight that we want in the product. So we know which mass we want to work with. And then we shape it. We simulate it. When goal is reached, we put it through our suppliers for to check if it's something producible in scale. And otherwise, there are always small adjustments. We mostly deal with extrusions. So, you know, you always have to check the right thickness at the right spot. Otherwise, the aluminum extrusions cannot be made. And then we finally rerun our thermal simulations. And we get to prototyping stage when we do all the different tests in the laboratory with our heatsink.
Okay,
so
great.
It's a little bit long process, but it's a very key component. It's actually, we build the lamps around the heatsinks. So everything in the lamp, which is not a heatsink, is there just to hold the heatsinks and the electronics.
Wow, okay. And I think that Sandil has asked a similar question, this being, you know, does a warmer environment affect the cooling of the floodlights? So I suppose, of course it does, but you and the team, and we would build the lighting solution knowing the environment, and would provide a solution knowing the situation it's going to be in.
Because I mean, yeah, the main parameter when building a heatsink is, yeah, it's the junction temperature, but it's the delta between the ambient temperature and the junction temperature. So that is actually the second input we put in, which is maximum TJ and maximum ambient temperature allowed. Okay. So it starts with that.
Great, thanks, Paolo. Yuli, just coming back to you on to question 11 here. We do get asked this quite often. You know, a partner of ours will come in and say, you know, we've got a project proposal from a competitor that's using more lamps at a higher power. So why is the Midstream proposal offering a lower quantity or a lower power?
Yeah, so this really goes back to, I think, what I was mentioning about the design element, right? So because we have our proprietary optic lenses, and these optic lenses allow us to deliver the light where it needs to go, it allows us to have a higher efficiency and efficacy of the products. And so, in essence, the design, together with our experience of using the design and also our optic lenses, we can often deliver the required lumen at a lower number of floodlights or lower power than perhaps other products. And also don't forget that, you know, we have experience of running thousands of projects. Quite often you have local teams or design consultants that may be doing a project as part of a big piece of work, and their experience may be doing, you know, 2 or 3 lighting designs a year. So they have to be a little bit extra careful or cautious, they overcompensate. So there are many reasons why that could happen. But typically what we do see is that we are cheaper on the overall cost of a project because we're optimizing the unit numbers or the type of floodlights. And so the value to the customer would be in that design knowledge and the ability to be very particular in how we design. We don't need to overestimate our proposal because we know how they perform in the field. And I think that's where our key advantage is. But you can flip this question and say, on the other hand, why do you sometimes have more floodlights than competitor proposals? Okay, and that's the other side of the medal, and that's where, okay, that's where you could have certain companies competing on a certain project, but not understanding the full requirements and therefore using lower number of luminaires and quantities and not necessarily meeting the requirements of the customer. And so that's where the trust element in your partner and supplier is critical.
And also, I would like to add, so I can actually at the same time answer Marcel's question, because he's asking, what if the customer set a maintenance factor of 0.7 in the scope for everybody to calculate with? Is it a fair deal? Sometimes you will find proposals from other companies using fewer luminaires and lower power, and we look at it like, this doesn't make sense. And so maybe it's a port terminal and they use a maintenance factor of 0.95. That means they only allow for 5% lighting depreciation over 12 years lifetime while installed in seafront. So that is a very bad thing to do, because you will fall out of regulation very soon. And to answer Marcel, yes, it is a fair game when the customer specifies the maintenance factor, as long as the competitors are also weighted on the L90, or in this case, the L70 of their product. Because if you use a maintenance factor of 0.7, but your lifetime is a third of one of your competitors, then it's not a fair game. You should use 0.7 and your competitors should use 0.4. You know, it's so they always have to be two parameters. They have to go together.
Sure.
And Michael, it's actually a very deep subject, this, and it's actually quite close to my heart, because I have to continuously discuss this with customers. And what you could have as a consultant, a lighting vendor, a wholesaler that's picked up a piece of flux software, so the LDT files or the IES files, the photometric files of a product, he's plugged them in as they are, and he's done lighting simulation. But he does not know how they perform in the field, because in reality, he might need twice as many of them, or he might need twice the power to actually deliver that lighting level, those lux levels on the ground. But because they have no experience with the product, or they have little experience with that particular product and how it operates in that environment, Okay, they just put a quantity in and they hope for the best. And that's where, again, it goes down to the experience and knowledge of how products perform out in the field. That's when you choose the correct number and the correct power.
Okay, great. Thank you very much. Yuli, I'm actually going to come to you as well and ask this question again. It's something that comes up all the time. Where are your products and components manufactured? I obviously briefly mentioned on it in the opening, but I think it's a really important point for our partners, our clients, our peers who are on the call. So where are our products and components manufactured, and why is that important?
Actually, it is the most common question when we are exhibiting somewhere, for example, at Light and Building, which was cancelled this year, unfortunately, and coming back in 2 years' time, or Light Fair. The first question, one of the first questions that we have when somebody new comes onto our stand is, where are your products manufactured? Okay, and I think that, well, the answer is we manufacture them in Europe. So the Titan range and the Flare range for horticulture is manufactured in the UK. And then the Modus and Atlas range is manufactured in Romania. And the reason for that is the high quality control. So we can get to site, in the UK within a few hours. And likewise in Romania, we can be there in the afternoon if we need to do some checking. All of the metal work is, delivered to site. It's bent, cut, painted on site. All the assembly is taken there. All the components, although some of them, of course, are manufactured in the Far East, we source them all from our supply chain in Europe. Okay, so we can get answers pretty quickly and within our time zone for any issues that happen. And we have full traceability, all to in the minute component level as well, so we can understand what the batch is, what the component has failed and why. And of course, we operate all of this in line with the ISO 9001 management system. As well as the 14,001 and 45,001 management systems.
Sure. And again, for our partners, we can provide you with lots of information on products and manufacturing if it becomes a conversation that you're having with clients and they want to be able to see, touch and feel the environment. We have some incredible photography and some great data. And as Yuli said, certifications around our manufacturing. It's something we're exceptionally proud of and more than happy to share.
And always welcome, we can always arrange site visits to either manufacturing plant. We do regularly take customers to site so that they can see the manufacturing for themselves and they see the full cycle there. In addition, we always have audits of our facilities by UL and NEC. So that happens almost on a quarterly basis. And then, of course, we have certain customers that send their own inspectors before shipment to comply with letters of credit requirements and things like that for big orders. So at any time, if somebody needs to schedule a visit, then please get in touch and we can do so.
Fantastic. We had a question come in from Kevin based around the implications of CLO, so constant light output, in the floodlighting design process. Is this practice employed within our sector as well? I know Kevin works across many different industries from a lighting standpoint. So I think from his question, it's understanding, is this something employed in our sector as well?
Well, let's say the constant light output in a luminaire just basically means that the moment you turn on your floodlight, from the moment you turn on your floodlight, it will start to slowly increase the current at which it drives your LEDs to following a preset trend which sits in your power supply. The biggest implication is that this is done to compensate the loss of flux of the LED chips, and allows the customer or the designer to use a maintenance factor closer to 1, but not 1 like we see sometimes, because you again have dirt and other type of depreciation. Let's say that the biggest implication while designing a floodlight that has this feature is that you have to account for the power consumption of the last day, because it's not going to be the same as day one. So you have an increasing power consumption in your product. So thermally, you need to account for that. And again, regarding the actual lighting design, the only thing it allows you to do is reduce the maintenance factor you're using. We are not a big fan of constant light output. We rather have a very low depreciation and concentrate on that. But all of our products are capable to be offered with CLO activated, because all of our drivers are programmable and are able to store this curve. It's just that I do not trust it. I think it lowers the reliability of the product, actually. It gives the opposite effect of what people are looking for. Because if the depreciation is very low, what I'm doing is just I'm increasing current on an aging component. So it's something which, you know, it decreases its efficiency as it grows older, and I'm stressing it even more. And the more I stress it, the more it gets older quickly. So I think having a controlled aging, since anyway we're talking about 10% over 12 years, I think it's something definitely manageable from a design point of view, rather than having all the drivers programmed with a function like this.
Okay, great, thanks, Paolo. Yuli, got a question that came in from Mohammed with regards to standards within aviation aprons, and he said that for a calculation for apron lighting design, it mentioned the lights should reach the end of the apron, but he's seen in other documents that the light should go to a max of 10 meters beyond the AC tail. So what is the correct one to use, the correct calculation? What should we be thinking about?
I'd like to know which document Mohammed refers to for the 10 meters beyond the aircraft tail. Maybe Paolo knows. I haven't come across that myself too often.
I think he's referring to, well, because I mean, I don't know exactly what document he's talking about, so, but I can assume that he's looking at a document where the threshold of the aircraft stand is not defined, because ICAO asks you to calculate the entire surface within the limits of the stand. Usually the stand is designed to be within X meters above the maximum aircraft size that can fit there. But there are also cases of airports where you only have the central line traced on an aircraft stand, and you don't have any outer limits. So in that case, you have to consider the biggest class, the biggest airplane in the biggest class that can park there. And then, I don't remember the rules by heart right now, but then you go from the maximum wingspan and the maximum length, and you have to add a certain size and calculate your grid there. So
Paolo, my approach would probably be to, because the ICAO refers to the aircraft stand. It doesn't refer to the apron. Okay, so we have to be clear about that.
Yeah, so, sorry, stand I meant.
Yeah, so what I would probably do, yeah, you said it. So what I would probably do is consider the biggest aircraft that parks on that stand and identify which category of aircraft stand that belongs to, whether it's a code A, B, C, D, E, or F. Okay, and you can, there is a list of aircraft type and which code of aircraft stand it belongs to, and then design to that code. So for example, if the code E, then I think it's 60 meters by 60 meters, something like that. And the code F is 80 by 80. So depending on the code, that's how we do it. Because at least that way you can link it specifically to a standard.
Yeah, I agree.
Great, and we have one final question. This came in actually pre the session over email. In aviation and sports lighting, from which level is the lux level calculated, from the ground or any other factors?
Well, this actually depends on what regulation we're applying. Let's say that usually horizontal light level is always calculated on the ground because that's where actually the lights ends up. It's calculated above ground if the work plane is identified to be above ground, so it could be at 0.75 meters if the work plane is considered to be at table level, or 1 meter, 1 meter or 1.5 meters somebody's working standing up. In the airport especially, the vertical levels are regulated by norm at 2 meters, because they have to resemble the light hitting the start of the fuselage of the plane in two directions. And in sports calculations, again, depending on what league is regulating, is usually verticals at 1 meter and horizontal on the ground. But there's also instances of horizontal at 1 meter, because you're considering the players and obstacles on the field. So
okay.
anyways, in this range.
Okay, great. Thanks very much. And we've managed to fly by, and that's the full hour gone. We had a few other FAQs that we were going to bring out, but we'll save them for session 2. Thank you to everybody who has joined and asked questions live. Anything we didn't answer, Kevin will answer after. I've just seen you've popped another question in there. Don't forget that when you close down the session, there will be a Q&A that will pop up in another browser. Please give us your feedback, ask any questions, give more information. We're taking this all in, and we're developing these second sessions week in, week out to support you and what you might need. A massive thank you to Paolo and Yuli for putting together all the answers and for joining us again today. Really, really appreciate it. And thank you to everybody who's taken an hour at the day to join another one of our webinar Wednesdays. We really appreciate it. We love doing them and look forward every week to coming on and talking to you guys. So thanks again. Thanks to the team, and enjoy the rest of your day.
Thank you.
And thanks, Michael, for another expertly managed session.
No problem.